presentations by Mission. We are a premier AWS partner that has the data and analytics competency, and so we're working with lots of different customers. And one of the questions that often comes up is, how do I automate my reporting, right? That's a lot of what we're going to talk about today and go over the AWS services that you need in order to build out that automated pipeline. So, if you sit there and you're frustrated by your data being siloed or having inconsistent data where you're often trying to clean it all the time, and people working in Excel sheets and you just see really slow time to value, if that's the world you're sitting in right now, then you're in the right place today for us to kind of walk you through what we've done for a couple of other companies in the industry to really take their data analysts that were working in Excel or working in Tableau and turn that into an automated reporting infrastructure that they're able to just see those reports at the end of the month and get them very quickly and review them. And we set up a lot of ETL to keep the data consistent and pull data from a lot of different silos in their ecosystem. Next slide. So I'm just going to give you the intro, a quick little minute on what Mission is, who we are, and then Scott Clark, who's one of our big data specialists, is going to talk through the AWS ecosystem for the data analytics space and walk you through the customer pipelines that he's built out. Next slide, Scott. So who is Mission, right? We're a premier AWS consulting partner. This is the highest level of partnership that AWS has. To get this, you have to have a lot of competencies, which we'll go over in the next slide. You have to have a lot of team members that work in AWS. So we have over 150 certs in AWS, over 220 members on the team, and we have 400 plus customers that we work with. And a lot of that comes through resell and MSP. Mission offers all the different parts to help you with your AWS solutioning, whether you need resell and cost optimization, whether you need managed services or professional services, which is where Scott and I work out of. And that's where we really help enable customers on the AWS stack. Next slide, Scott. So as a premier consulting partner, we've been validated and vetted by AWS. We have our data and analytics data and analytics competency. We have our well-architected partnership, our immersion day partnership, Redshift delivery, and then we work in a lot of verticals: healthcare, life sciences, SaaS, migrations, DevOps, all the different key pieces that could help you. Next slide. Here's just a quick slide that's on a lot of the customers we've helped in the various spaces. You can see that we work with customers that are very large enterprises like the Boston Celtics, DreamWorks, to smaller companies that are out there like wine.com, Encino. There's a lot of really, really good work that we've done along all the different verticals, whether it's entertainment, whether it's life sciences, media, financial. You guys are in various fields. We've probably done work in that area. Next slide. So today's talk is really going to focus on the state of data today, right? So as you guys probably know, the data is just growing exponentially. You're getting data from your own systems, as well as there's so many data sources out there that you can subscribe to and get additional insight in. The data marketplace is awesome. You can easily pull those data sources into AWS. Many of you have probably already used Glue. Glue has tons of different connectors that allow you to pull that data from third-party APIs, as well as build your own for your internal resources. And it's becoming increasingly more diverse out there. You're seeing tons of IoT data coming in. You're seeing with that IoT data, whether it's sensors, whether it's images, whether it's sound data, there's all kinds of awesome data, and the diversity is just becoming enormous. And how do you handle all of that diversity? And then building out that central repository on AWS is how companies are getting out of using that silo, right? Because now you're able to land it all in S3, figure out how do I want to kind of do my partitioning strategy, and then how are people going to use that? How do I set up all of my IAM roles and everything else, right? So that security piece is pretty big. And then finally, there's tons of AWS services and other third-party services out there to just look at that data, analyze it, right? And Scott's going to go through all of these pieces and all the different services that you see on AWS. Next slide.
Okay, thank you, Ryan. Thank you for that introduction. And again, thank everyone for joining us here today. We've got quite a bit of material to cover, so we'll jump right in. We're going to start by laying some foundational work and understanding what a modern data analytics architecture, what does that really mean? What does that mean on AWS? And using AWS Serverless framework to help drive modern applications and modern data analytics. And then we're going to walk through the services, and we're going to do that in sort of a by domain, if you will. There are a lot of services. There are by no means have we listed every one of them, but we wanted to provide at least a pretty wide breadth of the depth of services that are involved in the analytics platform. And then we have two case studies. One is a biopharmaceutical company, which we're going to walk through at a high level what the case study was, what they were trying to accomplish, and what their pain points were. And then we'll walk through the actual solution architecture that we did for each one of these, the biopharmaceutical and the renewable energy company. And then we'll put it all together at the end, and I believe we have some polling for those, and we certainly welcome your questions. If we've got a lot to cover, so put them in the chat. We'll try to get to them during the call for sure, or at the end. If we don't, definitely we'll respond to you via an email. So, poll question number one: how would you describe your organization's data analytics journey in the cloud? We are starting to explore the possibilities of analytics in the cloud. We are conducting POCs and MVPs for our data analytics pipelines in the cloud, or we have production level analytics and machine learning workloads currently running in the cloud. Okay, great. Looks like we've got that. Let's move forward. Thank you, Melissa. Oops. Okay. So the stages of the analytics pipeline, right? We have our data sources, and then most everyone's heard about the 4 V's of big data, volume, velocity, variety, and veracity, right? So these data sources can be streaming, they can IoT devices, they can be batch, they can be structured, they can be unstructured. So it's just as Ryan alluded to earlier on, just a lot of different ways, a lot of different data out there, a lot of ways to get it in, and the speed and volume of that is paramount in selecting the right architecture and tooling. So what we have is we have ingestion, we ingest, we process, we store, we secure, and we govern. Then we consume, and to tie it all together, we have to orchestrate that. So as you can see here, we're ingesting, we're putting that into our storage layer at a raw level. We're kicking off through some event or trigger the first level of processing of some transformations there. We're putting that back into another zone. We're calling it your clean. It could be a lot of different enriched, etc. We trigger another function, and we go out and we enrich that data, and then we put it all back together in a curated and consumption zone. The whole time we're in that processing phase, we're cataloging that data, and so it's easy to find and easy to search, easy to manage schema changes, etc. And then we're securing it and governing it throughout the process. Sorry about that. My mouse is very sensitive. So what does a modern data architecture really mean? Well, choosing the right data architecture is central to success of your data strategy. It's made up of policies, rules, standards that govern and define the type of data you're collecting, how you use it, where you store it, how you manage it, and integrate it into your business. And so with the modern data architecture, everything is built around the data lake, okay? And the key takeaway here, or always be thinking, is minimize moving the data and move the compute closer to the data. And so you'll see with AWS services, how we accomplish that. But you have your purpose-built databases. It's not a one-size-fits-all anymore. There are relational databases, no SQL databases. You want to drive your machine learning. You want to drive your enterprise data warehouse, and so forth. But everything is revolving around the data lake, and that's central to the process. So what does that look like on AWS? We've said it once before, but we have, amount of data being generated by smart devices and applications is growing exponentially. We sort of all know that. But what do you want? You need to be able to easily, cost-effectively analyze that data and minimize the time to insight or time to value, regardless of the format of the data and where it's stored. You need to be able to query that data easily in the data lake, and you need to be able to write that data back to the data lake for other downstream applications and services. You really want to use tools that your organization is strong with SQL, to do a lot of the ETL processing and enrichment of data. And then you want to be able to execute queries on live data in other databases. So, through something called federated queries. We're not trying to move the data, we're trying to access the data and get the compute closer to it. So everything in AWS in this modern architecture revolves around S3, Lake Formation, and Glue. There are other services that can handle the what I call formalization of the data lake. But essentially we'll get into it more, it's really formalizing that data lake and providing fine-grained security and cataloging so that you know what's in there. And then we're serving that data up, to our machine learning pipeline or into our Redshift cluster, or into, an EMR cluster for further, processing. So I think it's important to understand what is serverless. Let's just define it. Take a moment. A serverless architecture is a way to build and run applications without having to manage infrastructure. It doesn't mean there aren't servers. It just means that AWS has taken the heavy lift on provisioning, patching, all the tedious tasks that go along with processing data. And so you're not in a position to have to scale it, go buy new, more storage, more compute power. What's that really buy you? You can move from an idea to market much faster. You can adapt to scale, and you can lower your cost. Why serverless? Because now you can take those resources that you've been dedicating to managing infrastructure, servers and the likes, and you can refocus that energy and get value of building your products better. And so what's the use case for data analytics? Well, in AWS, it's not just AWS, but there's a serverless framework that we work with. And it uses services like Lambda for serverless compute, API gateway, transfer family, DMS, Glue, Lake Formation, Athena, and Quicksite to implement this modern data analytics architecture and reduce the operational complexity of your pipeline. So let's go to principle one. We talked about ingestion, right? Here are a list of services that do that. within AWS. Again, I'm going to state that it's not necessarily all-encompassing, but it is a pretty good representation. And we don't have time to go through each one of these and each one of the different principal areas. So let's take a look, and let's just start with a very simple one. AWS Transfer Family. Most everybody's worked with FTP or SFTP. What Transfer Family is a means of moving files between your business partners, your business units, and manages that workflow on the back end to get it into S3, and you're not managing these servers. So it's providing a highly secure means of doing that. Then we have, I might want to back up just 1 second to make a clarification. A lot of people confuse, serverless versus managed services. For the sake of this conversation today, let's just use the two as synonymous, right? Managed services and serverless, to play in the same ballpark. So database migration services. This helps you move on-prem databases, in the cloud databases, other cloud providers. So it supports both a homogeneous, let's say Oracle to an Oracle, or a heterogeneous, such as an Oracle or SQL Server to AWS Aurora. There, as Brian mentioned earlier, there are Glue connectors. And what this allows you to do is, you can go to the AWS marketplace. There are a lot of pre-built connectors. It also has the capability with its SDK to build your own custom connector. Another service that's near and dear to the data analytics machine learning team here at Mission is Kinesis. Kinesis is a family of streaming services. So you can build streaming applications with Kinesis streams. You can use Kinesis Firehose. Just as it states, it's like hooking up a fire hose and letting the data flow into some downstream systems. You can do some transformations on the fly there, and you're getting that data into your storage layer with some intermediate transformations. I'm sorry. The analytics piece of it, do real-time analytics in the stream, and be able to present that data back to your end user. There's obviously Managed Kafka, another very popular service that we work with. Then you have the Snow family, which this is where you're looking to go from on-prem or your service provider, and you've got hundreds of terabytes or petabytes of data. So this is not really serverless. There is a device that's shipped to you, and you plug that device in, and we're able to get that data up and into AWS and into S3 in a matter of days. Also, another favorite is AppFlow. AppFlow is a secure way to get your data out of your SaaS providers, your Salesforce, your Slack, your Marketo. You can, manage some change data capture in there. So you build a pipeline with AppFlow. And again, what we're doing is, we can filter it, we can map, we can validate, we can add some, calculated fields, and then we're getting it into our storage layer. Next, we're going to talk about principle 2, data storage and governance on AWS. I think anybody that's been on AWS knows S3. It is the backbone of a data analytics platform. It's highly durable storage, infinitely scalable, and offers many tools within the AWS, within the S3 family, to help you understand the trends in your data, moving it, lifecycle management. Your data's getting cold, warm, or you want to move it off and pay less. Those types of things. AWS Lake Formation. It is what I like to think of as a wrapper for your data lake. You know, the one thing that people used to say quite a bit when data lake first, you know, people started talking about data lakes was, you know, data lake versus a data swamp. Lake Formation is there to help you manage that with some very fine-grained access, you know, even down column level, certainly row level, and even down to cell level of data. So very powerful tool, works in conjunction with a lot of the transformation and Glue catalog. There's Macy, just real quick, you know, it's machine learning built on top of S3 that helps you identify, you know, where your sensitive data is and mask that. And it's that piece of it. Another thing that we like to stress is well architected. This is certainly not a serverless product, but it is a tool that helps you, our customer, work better with our team and really defining the priorities, you know, how we manage risk versus cost. And, you know, it's very well laid out documentation that, you know, leads us to a point where we don't have any stones unturned. We're able to account for it to the, you know, to the stakeholders, to the C-suite, as to what we're building. That's one. And then you've got your information, infrastructure as code. That helps you govern and make sure that, you know, all your policies are being maintained, your IAM roles, that you're using appropriate resources, you know, size those carefully. We on the data analytics machine learning team, DAML, as we refer to it here at Mission, really are big fans of CDK, which is the cloud cloud version of where it allows you to write your infrastructure as code in languages like Python, for instance. So principle 3 is the data processing and transformation layer. A lot of times, you know, you see that this is somewhat where the rubber hits the road in data and analytics. You know, people get bogged down. A lot of time is spent understanding their data, transforming it into usable formats. And so there's a lot of tools within the AWS ecosystem that allow you to do that. I don't know how EMR Serverless made it into this group, but we'll talk about that in a minute. That's a new service by AWS that really allows you to run Hadoop Spark cluster, you know, and scale it without having to manage any of the infrastructure. So that's a relatively new service. But Glue Studio is, you know, our means. It's a drag and drop way to manage your ETL workflow, manage the code and DAGs that go into that, and you know, it's all driven through drag and drop, point and click interface. So very powerful there. But you know, and it's allowing you to do things like sample that data, do joins, you know, view your schema, and one thing that we're not calling out right here is the Glue crawlers, which you know, help you catalog that data throughout its life cycle, so that you know where it is. You can control access to that catalog, and ultimately who can have access to that data by controlling access to that catalog. AWS Data Brew, something that we find very helpful, and you'll see it in one of the use cases today. It is a GUI interface service that you know, it's got a UI that allows you to perform about, this is a little out of date. Last I saw was about 300 different transformations that you can build in with Data Brew. And what you end up doing is you create recipes, and based on various events or triggers, those recipes are called, and you can process your data in a no-code manner. And a lot of machine learning transformations are built in, so really a cool product. Data Wrangler is similar to Data Brew, but is more, it's an ML, similar tool that works in the ML space and the SageMaker space. And then we have our Lambda function. Lambda is a serverless, event-driven compute service that lets you run code virtually any type of application or backend service without provisioning or managing servers. So it supports runtimes for Python, Go, C#, Java, Node.js, Ruby, PowerShell, and others. Very powerful tool, and we use it quite a bit in our architectures. Another piece of that is Fargate, which is containers as a service. It works with both ECS and EKS, so that's Elastic Kubernetes Service on AWS. You build a compute engine. You see on the far right, you build your container image, you define what it needs in terms of memory and compute, you run and manage the application, and Fargate is scaling and building out that underlying infrastructure to run those containers. So another very powerful tool that we like to call on frequently. Many other third-party tools, can be used in this process. So in principle 4, how do we do reporting and visualization on AWS? Well, one of the key services is Athena. It is an interactive query service. It makes it easy to analyze data in S3. It's serverless. It is AWS version of Presto, and so you're just paying for the queries that you run and how much data is being scanned. That being said, it's very important that you understand how your data is structured in S3, what formats it is in, so that you can help reduce those costs when querying the data. So it's pay per query, open, powerful, fast, and uses standard ANSI SQL for to a 99% degree. You have Redshift Serverless, a new recently announced service. You no longer have to provision, a data warehouse. Really good for small organizations getting started in this space, or data marts within larger companies. So your data is residing in S3 in the storage, and you go in, enable Redshift Serverless in your console, and you tell it how much memory and compute you need, and you start getting it with queries. That, again, important to understand your data architecture and to make those queries perform well and so forth. But in terms of building and managing a cluster, Redshift Serverless is taking care of that. Another part to the Redshift family is the Redshift Spectrum. And this is allowing you to, in a modern data architecture, we're trying to, separate compute from storage, right? And so what we're allowing here is to go out and really scale your queries across your S3 without having to, manage the underlying scaling of the cluster itself. Quicksite, another one of our favorite go-tos here on the DAML team. Very powerful cloud-based BI tool. 2 years ago, I would get people that would tell me it just can't handle what we needed to do. I would say for the most part, pretty familiar with Tableau and some of the others. Quicksite is a strong competitor these days. It has some built-in ML with anomaly detection and forecasting and NLP or natural language processing. It can scale massively. You can collaborate and you can collaborate with teammates or throughout the organization or with customers in this capacity. It obviously has an ability to white label it so that you could make it a front end analytics tool to your customer base. Very powerful, and we also work pretty frequently with the likes of Tableau and Power BI as well. And finally, what we're going to do is we're going to tie this all together and orchestrate this pipeline, and we have to have some tools in place to do that. Step functions within AWS. It's a low-code visual service that helps developers build distributed applications and automate IT and business processes. Synchronously, asynchronously, you can put humans in the loop on this, but it builds that pipeline, and through multiple ways, you can trigger on events happening. You can wait for a process to finish before another one starts, or you cannot. We also, another popular tool out there, and anybody that's worked with Airflow native knows that it's not plug and play. There's a lot of work that goes into building those clusters, managing the DAGs, managing the process. With managed Apache Airflow on AWS, that underlying cluster, Apache cluster, Airflow cluster, is managed for you. So you're more focused on your code, refining that code, refining your processes, and refining the pipeline so that you can move it quicker and faster into your decision pipeline. Okay, I think we have a poll here. So how long does it take on average to gain meaningful insights from your data? 1 hour, 1 day, 1 week, or more? Okay, great, good results. So it looks like the majority are looking at, there we go, around 1 day to get meaningful insights, with 1 week, not too distant seconds. That's great. That's interesting to hear. Thank you. So let's get into this case studies. The first one we're going to talk about is a biopharmaceutical company. Okay, the customer was a drug discovery company in the early stages of clinical trials. The problem, they were slow to iterate and gain meaningful insights into non-human clinical trials test data. On average, it took a week to produce value from the data. Not necessarily a great thing if you're trying to iterate and build a drug and get it to market before your competitor. The solution: build a serverless, touchless, code-free analytics pipeline that can produce insights in minutes. And we're going to see how we did that in just a moment. What did we learn? One key takeaway was unlocking the power of Quicksite visualizations and its built-in machine learning capabilities is a game changer. We were, if you think about the drug discovery process, you want to be able to quickly identify anomalies in your testing. You also want to be able to project if I change this formula or if I change this time, I'm pulling something out of the air here, but just say I'm going to change my chemical compound and how long I run this test or expose to this chemical agent. If you can start to begin to see that and forecast that, you can make better decisions about your testing going forward, therefore saving time, money, and moving your product to market faster. So the solution, we have test results, and those test results could be from, in this case, they were not, but those tests could be driven from mass spectrometers, that are IoT connected to the cloud or to a local file system. And so in this case, they weren't necessarily all microscopes, but we were grabbing the test results at an on-prem file system. That was an event trigger that would allow us to go out, and the event for us, if memory serves me right, was something more along the lines of a cron job. A couple of times a day, let's go out and get this data. That hit SFTP. That SFTP orchestrated that to get in a landing zone bucket or a raw bucket, where an event trigger was triggered on Glue data brew recipes, and we were able to transform that data, convert some of the data types, convert the file format into an optimal storage, i.e. Parquet, and move that to a curated zone. Throughout that process, we had Glue crawlers that were going out and identifying the maintaining our metadata catalog, and so we could see, if schema changes were taking place and adjust to those schema on the fly. We used Amazon Athena, which we talked about earlier, to build views, query that data in S3. Really, we're querying the catalog, technically, and that's pulling the data back from S3. But those views were then exposed to Amazon Quicksite, which would automatically refresh the views based on where you were in the dashboard. We provided the customer, console access to that, but as well, we're moving towards, as they expand their footprint and become more reliant on the system, we are, SSO, kind of a federated access, right? Simply put. So any questions on the architecture of this? Okay, but please, we can save them for the end. You can feel free to leave them in the chat, and if we don't get time to address them at the end, then we will certainly respond back to you. So case study number 2 is a renewable energy company. The customer is an owner or operator of hundreds of renewable energy sites throughout North America. The problem, it took half a month to prepare, annotate, enrich, and generate management reports through a very highly skilled, labor-intensive workflow. Our solution, build a modern data analytics architecture using the existing refactored code. So they had a lot of complex code, and trying to untangle all of that and get to an MVP quickly was determined early on that wasn't the best use of our time. That's part of an iterative process. So we were able to refactor that code and be able to process all of this data, which was taking, you know, days upon days in minutes. And the lesson learned, provide a solution that can be iterated upon, scale exponentially in line with the customers, with the company's growth, projected growth. Walking through this architecture, a little bit more involved. We were using, you know, containers here, but let's start on the left. We have data acquisition systems. These data acquisition systems are all taking in essentially IoT data from these different sites. The equipments, the inverters, everything that would go in to a renewable energy power processing site. All of that data is fed into these data acquisition systems. We used some existing Python code and wrapped that. We upgraded that code in many instances, modernized it some, but didn't change all, you know, a whole bunch of the logic here, just for, you know, the sake of let's get to an MVP, and then next iteration we start untangling the code. But so, and then we have a SaaS system. The SaaS system is maintaining, you know, a lot of the work order data, and throughout, you know, throughout the month, and as well as it's capturing, you know, some of the real-time data is being captured there. Not all of it, as you can see from these other data acquisition systems, but reporting is driven out of this SaaS. And so we have Lambda functions going out and capturing this data and ingesting it into S3 landing zone. We have our AWS app flow talking to the SaaS provider and getting our work order data in a change data capture mode, right? And we're writing that to S3 in a landing zone. And so then some transformations happen, and in Glue, which is event driven and kicks off some step functions, and in those step functions kick off containers, and we spin up about 400 different EC2 instances to parallel, you know, massive parallel processing. We run that job, and that finishes in less than 5 minutes. There's been occasions where it's run outside of that window, but certainly less than 10, at a cost of around $5 to process all that data for its first pass through. That data is then sent to process. There are some other transformations that are taking place there, but what you'll see here is there's an annotation team in the human loop, and this is highly skilled. You know, this group of people needs to be very familiar with data, anomaly detection, also, you know, historical data. They have to be able to pull from historical data to fill in some of the missing pieces. Like think about snowfall or weather-related issues. Sometimes that's not necessarily available for a site. So you have to look, you know, at historically a site that was in, you know, a certain radius, so to speak. And so you have to be able to pull all that data in, and a very trained eye has to sit there and make a lot of that annotation. And you'll see over in future state, what we're going to be doing is we're still in this iteration, still running that process. It's still manual, but we're now starting to capture all that data and these changes that this team is doing throughout this process. And so when that's being captured, you know, we've got the beginnings of really building a machine learning pipeline. So maybe not next iteration, but iteration after that, that human loop will pretty much go away. And this will all be driven by machine learning. So moving down from there, the change data capture happens in annotation, the enrichment happens at the annotation team, and they process it to curated bucket. And you see throughout this process that, you know, Glue crawlers are tracking that data from the time it lands all the way through to its curated state, using Athena again, Quicksite, to build views that are then exposed in Quicksite to the dashboarding. And these, you know, obviously there are varying user levels there. Some people can see all the data. Some people can only see one, you know, one site, one report. So building that logic and fine-grained access, well, it was a big part of that. And so then we, you know, able to send out to their stakeholders, their stakeholders, you know, PDF reports, because that's what they're familiar with getting right now, you know, that are obligated to do. And then you have more internal or, you know, the analytics team, you know, logging in Quicksite and really beginning to build out these dashboards and, you know, make some very valuable decisions, business insights to management and internal stakeholders. So that's the architecture in a nutshell. Again, any questions, comments along the way? Okay, great. It's all sinking in then, right? So let's put it all together. We've talked about ingestion.
So Scott, we do have a couple of questions coming in now.
Oh, okay. I don't see the question. I'm sorry.
So question number one, if you go back up to use case 2, they're asking how is AppFlow used in this use case?
AppFlow is connecting to an API for the SaaS provider. You know, that's exposed to the SaaS provider, and you know, it's ingesting that data at a regular cadence.
Scott, in this case, AppFlow is connected to Salesforce, right? So that
yes, correct.
You can pull the data from Salesforce using AppFlow.
Yes, yes, a flavor of Salesforce.
Yeah.
Okay.
And then the second one, were the reports and dashboards displaying data real time? None of these use cases that we're showing right now displays data real time. But Scott, when you go to the next slide, maybe just touch on how you would enable real-time dashboarding.
Yeah, okay. But to add a little finer point on that, it is minutes. It's not hours, but it's not, you know, instantaneous, as Ryan said. Okay. So let's put it all together, and then I'll touch on what we got a few minutes left here. Putting it all together. So we have our data generating sources, and we've got to connect to them through some method, tool or service to input that data and get it ingested into the cloud and into S3. A couple of services that we didn't call out here: data sync, you know, for mobile apps, keeping data sync with mobile apps. We called out Fargate, and then up at the top you see data exchange. Well, it is a platform on AWS that allows you to buy curated data or subscribe to curated data. So if you need to enrich your data, you know, chances are there may be some data out there for you to help you enrich your data that you can purchase and subscribe to. So we're going through the processing layer, the storage and processing layer, which we've covered. You know, we're using like Glue Studio to orchestrate this, or Glue Data Brew, or just straight up Glue native Glue, transformers. I think Ryan mentioned earlier, I want to back up about Glue connectors. I think we talked about that. That's another way of ingestion, right? And so with that, we're using, you see the step functions here are driving all that processing down at the lower part of the storage and processing block. And then we're running those catalogs to maintain our meta catalog, serviceability downstream to all of our downstream applications, whether they be the Redshift cluster, the Athena queries, the SageMaker pipelines, etc. And we're maintaining that catalog and access control within Lake Formation. Along the bottom, we're securing it by having very tightly scoped VPCs, public-private, non-accessible type VPC environments that can only be accessed from internally from one VPC to another. We got IAM, Lake Formation, KMS for encryption and key management, CloudTrail and CloudWatch for a lot of our governance and so forth. Talked a little bit about control tower. Two key parts here are the CloudTrail and CloudWatch, where we can build alarming and event triggers off the CloudWatch. And so then we've loaded that data into that consumption layer, and we're using, as we've talked extensively about, Athena, Quicksite. We touched a good bit on Redshift and SageMaker, but there are third-party tooling pretty much along any of this pipeline that if you are, I would say, if you're married to or you've made an investment in, that we can integrate with this in most cases. I will say that, I'm stretching here a little bit, but in most cases, those are not serverless. There is some management layer to that. I mean, that can be abstracted to some degree, but it's not necessarily serverless or managed in AWS parlance. Questions, comments, concerns? Here we go. Oh, we have
no more. It doesn't look like anyone's putting questions in. So.
Oh, okay. You wanted to talk about? I missed your point, right? I'm sorry. You want to talk about how to make it near real time. We make it real time. We could use Kinesis, one of the Kinesis families, and excuse me, or Kafka, manage Kafka, and build out that streaming pipeline. We've done that with the customer that was running about 6 million messages a minute, and use Kinesis to do that. Use Kinesis data analytics in the pipeline to report back, for some real-time dashboarding, to detect anomalies in the pipeline, spikes in the pipeline, so we can feed that message back to a real-time dashboard. So you would build that streaming architecture, using Firehose as well, and then we would get that into the analytics layer, which you can make Quicksite pretty much in real-time dashboarding, but there are other tools, Kibana, Grafana, there's a lot of tooling for real-time dashboarding. Quicksite can handle that. I don't say it's its strongest suit, but yeah, just building that streaming pipeline with managed Kafka, or the Kinesis family.
Okay, awesome. There's one more question that we have here. How do you determine between using Kinesis versus Kafka or MSK?
A lot of people one is pub sub, and the other you have to manage. There's some management of sharding, right? So if you're comparing Kinesis streams to Kafka, there is a little bit more of some heavy lift on the Kinesis side, because of managing the applications, the APIs, and the sharding of those. Whereas your scalability on managed Kafka is better. But managed Kafka is a real game changer in terms of managing the Kafka cluster. If you like to stay AWS native, you know, you can, sort of a rule of thumb is if it's an AWS service, it's going to have more connectivity and more, you know, ways to plug and play with it. So that would be a determining factor. But then you know, what do I really need to do with that data? Do I just need to push it through a pipe and get it into my analytics? Do I need to, you know, what kind of transformations do I need to do in that? Do I need to report anything off of that pipeline? So there are a lot of things that make that determination. A lot of customers, you know, that have a certain degree of sophistication really like Kafka and want to move towards a managed Kafka. People more or less starting out, you know, Kinesis can be a better alternative there. And it's a little better at managing costs too.
Let's see.
We're at time.
Well, we got. Oh no, that's thanks. That was helpful. Yeah. So just at the very end here, with Mission, we do offer a complimentary 60-minute data assessment. If you would like to speak with somebody on our team, a data architect like Scott, to understand, you know, what more you can do with AWS, you know, feel free to reach out. You know, if you answer yes to this quick poll, you know, the team will also reach out to you for that as well.